Hi class, this is lesson 4.1, apply the triangle sum properties. Our big question is how do you find the measure of the third angle of a triangle if you know the measure of the other two angles? And we have a bunch of key vocab right here. There's a frame for lesson 4.1 that you should have filled in already. So let's do example 1, classify triangles by side and angles. It's talking about a shuffleboard court here. Classify the triangular shape of the shuffleboard scoring area in the diagram by its sides and by estimating its angle measures. So here's my triangle. Let's look at the angle measurements first. So this first angle measurement, that's definitely less than 90. That would be less than 90, and that would be less than 90. So since all three are less than 90, this is an acute triangle. That's the name based on the angle measures. And we see here that we have two sides that are marked congruent, and this third side is not marked congruent. So with two sides being the same, it's isosceles. So we would call this an acute isosceles triangle. This extra example 1, draw an isosceles right triangle and an obtuse scalene triangle. Let's start right here with an isosceles right triangle. I think it helps first to draw your right angle. So I have a right angle, and to make it an isosceles, I'm going to make these two legs about the same amount, and I'll just put my markings saying that they're the same, and then connect them. There's my isosceles right triangle. Now we need an obtuse scalene triangle, so I'll start by drawing my obtuse angle. And since it's scalene, I'm going to make these two sides different lengths, and then my third side will be still a different length. So that would be an obtuse scalene triangle. Alright, let's work with our triangle sum theorem. So theorem 4.1 is the triangle sum theorem. The measure of angle A, so this angle, plus the measure of angle B, this angle, plus the measure of angle C, so that's the third angle of my triangle. If I add them all up, that's going to always equal 180 degrees. So the sum of the measures of the interior angles of a triangle is always, always, always 180 degrees for a triangle. My next example 2 here, it says find angle measures. Find the value of x, then classify the triangle by its angle measures. So I've got a 60-degree angle, a 60-degree angle, and I need this one right here. So I know the three angles have to add up to 180, so I can say 60 plus x equals 180. 60 plus 60, that's 120, plus x equals 180. If I subtract the 120 from both sides, find that my leftover angle is 60 degrees as well. So this x is 60 degrees. And since all my angles are 60 degrees, this is an acute triangle. But even better, since they're all the same, we're not going to say acute, we're going to say it's equiangular. Since all the angles are the same, this is an equiangular triangle. Let's look at our other triangle. So for this other triangle, I can say x plus 3x plus 60 equals 180. X plus 3x, well that's 4x, and if I subtract that 60 from both sides, I have 4x equals 120. Divide both sides by 4, and x equals 30 degrees. So x is 30 degrees there, so let's see here. This angle right here is 30 degrees. This angle, instead of 3 times x, it's going to be 3 times 30, which that's 90 degrees. And then my other angle is 60 degrees. This is a 30, 60, 90 triangle, and since that is a 90-degree angle, we know that's a right angle. So this is a right triangle. Alright, well let's look at the next part. Let's now look at our exterior angle theorem, and pay close attention to this. This is one that students often mix up. So the measure of angle 1, this is the angle on the outside. That's my exterior angle for this triangle. That's going to equal the measure of angle A plus the measure of angle B. So the two angles that do not touch it. So it equals the measure of angle A plus the measure of angle B. This is the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent, so that means non-touching, angles. So let's look at our examples here. It says use the diagram at the right to find the measure of angle DCB. So D to C to B. We're looking for the measure of this angle right here. So I know I'm going to have to find x first and then plug it in to this expression right here. So it says write and solve an equation to find the value of x. So we can say 3x minus 9 equals, and we can add these two pieces together to use the exterior angle theorem. So that equals 73 plus x. And then we want to solve this. So let's put our like terms on the same side. I'll move my x over here. And I'll move my 9 over here. So 3x minus x is 2x. 73 plus 9 is 82. And if you divide both sides by 2, you'll find that x is 41. So next, we're going to substitute 41 for x and 3x minus 9 to find angle DCB. So instead of 3x minus 9, we're going to do 3 times 41 minus 9. 3 times 41 minus 9 is 114. So the measure of angle DCB is 114 degrees. Let's look at our extra example here, and it'd be a great idea for you to pause it and try this one on your own. Okay, so let's see how you did on this problem right here. So it says find the measure of the exterior angle. We're looking for this angle right here. So we're going to say 3x plus 6 equals 24 plus 2x plus 18. So I just added my exterior angle. Well, I didn't add it. I set my exterior angle equal to the sum of the two non-adjacent interior angles. So if I combine my like terms on the right side, I have 2x plus 42 equals 3x plus 6. Move my like terms to the same side by subtracting this 2x. And then we can subtract this 6 to move it to the other side. So now I have like terms together. So I have x equals 42 minus 6 is 36. Now the question says find the measure of the exterior angle, and we haven't done that yet. So we're going to do 3 times 36 plus 6 to find the measure of our exterior angle. And if you simplify that, you find that it's 114 degrees. And what I would do then also is plug 36 in here, do 2 times 36 plus 18, and add that to 24, and you'll find that you also get 114 degrees. So they're the same, they're equivalent, and that's what you would expect. Again, pause it and try this next one on your own. Okay, it says find the measure of angle 1. So this one's a little different. We want this angle right here. So in order to do that, we're going to find x, we're going to find our exterior angle, and then we're going to find angle 1. So we can say 3x plus 16 equals 52 plus 2x. And I'm going to move my like terms together on the same side again, so I'll subtract that 2x, and I'll subtract 16 over here to move that 16 to the other side. And I have x equals 36. Now I need to find angle 1. So in order to find angle 1, I'm going to plug 36 in here. That's 3 times 36 plus 16. And if you simplify that, 3 times 36 plus 16 is 124. And if you notice, these two angles together, they form a linear pair. So I know that angle 1, or the measure of my exterior angle, 124 degrees, plus the measure of angle 1 has to equal 180 degrees because they're a linear pair. So I can find the measure of angle 1 by just subtracting that 124. So the measure of angle 1 is 180 minus 124, which is 56 degrees. All right, let's look at our last page here. This is the corollary to the triangle sum theorem. So if I have a right angle, and this is the one we'll use often, the measure of the other two angles that aren't the right angle, that's always going to add up to 90 degrees. So it says the acute angles of a right triangle are, well, if they add up to 90 degrees, that means they are complementary. So let's use this idea in an example problem. Example 4 here. Find angle measures from a verbal description. The front face of the wheelchair ramp shown forms a right triangle. The measure of one acute angle in the triangle is 8 times the measure of the other. Find the measure of each acute angle. So what that's saying, if one of these angles is x, the other one's 8 times as big, so that other one's 8x. And this is a right triangle, so I can put that there. So what I know is that if I add this and this together, it's going to add up to 90 degrees, which is what we do here. So x plus 8x equals 90. Well, x plus 8x, that's really 9x equals 90. So if you divide them both by 9, x equals 10 degrees. So the measures, let me change my color so you can see a little better. So the measures of the acute angles are, well, one is x, so that's 10 degrees. And the other one is 8 times x, so 8 times 10, that's going to be 80 degrees. And 10 plus 80, yep, that adds up to 90 just like it should. All right, let's look at this last one here. It says in example 4, what is the measure of the obtuse angle formed between the ramp and a segment extending from the horizontal leg? So that's saying if I take this triangle and extend it, what's the measure of this angle right here? And we know that, well, that's a 90 degree angle and this is an 80 degree angle. So we know this angle equals 80 plus 90. So 80 plus 90 is going to give me 170 degrees. And that's the end of the lesson. Please make sure if you have any questions you ask me about it in class, and have a great day.